So to solve an equation for get all the solutions in the interval from 0 to 2 pi, first isolate the trig function. So we got to get rid of the -2 here. So we are looking for when is cosine negative square root of 2 over 2. Well, from the unit circle, square root of 2 over 2, that would happen at all the pi over 4s. Since we're looking at negative, we're looking at the pi over 4s in quadrants 2 and 3, which means x is the pi over 4 in quadrant 2 would be 3 pi over 4, and the pi over 4 in quadrant 3 is 5 pi over 4. There's our two solutions. Sine squared minus 1 equals 0. There's actually a couple ways you could do it. I would just move the 1 over this time, though. You could replace that with a cosine squared and negative cosine squared. But just add the 1 over. Sine squared equals 1. Since that's sine squared, we need to square root both sides. So that means sine equals the square root of 1, which is 1. And sine equals 1 only at one place, and that is pi over 2. That's the only solution on the unit circle. Since it was square root, we do need a plus minus. So it equals positive 1 at pi over 2. It equals negative 1 at 3 pi over 2. If you did the Pythagorean identity and changed that to negative cosine squared, you just look at the same answers because you get when does cosine equal 0, those 2 points, pi over 2 and 3 pi over 2. So in order to solve this, when there's a sine and a cosine, it doesn't really work out so well. So turn to your formulas, and we have a formula that says sine of 2u from the double angle formulas equals 2 sine u cosine u, which looks quite a bit like that, except that's a 4 instead of. So in order for it to be a 4 in front, you have to multiply by 2 here and 2 there. So that'd be 4 sine u cosine u, and that's 2 sine 2u. So 4 sine cosine is the same as 2 sine 2u. And we're trying to solve it out, so divide by 2. We get sine 2u equals 1/2. Sine equals 1/2 at it's positive, so it's in quadrants 1 and 2, and sine is 1/2 at the pi over 6s. So it's pi over 6 in quadrant 1, and 5 pi over 6 in quadrant 2. So that solves for what the angle was, and the angle was 2u. So finish it off, plus 2n pi plus 2n pi. Because since there's a period change, we're Rather than getting 2 answers, the period's actually cut in half, so we should get 4 answers. So divide by 2, you get pi over 12 plus n pi, and 5 pi over 12 plus n pi. So pi over 12 is our first answer. 5 pi over 12 is our second answer. Plug in 1, so add a pi to it. That becomes 13 pi over 12. Plug in 1, so add 12 pi over 12 to it. You get 17 pi over 12. And if you added any more, we would be outside the 0 to 2 pi requirement. So here we have a problem. We've actually got multiple pieces to it. First, there's cosines and sines, which is not good because that's hard to factor. Additionally, it's got 3 terms, so at some point we will be factoring to the 2 sets of parentheses. But before we can do that, we need to make them either all be sines or cosines. So let's change cosine squared. Using the Pythagorean identity, sine squared plus cosine squared equals 1. That means cosine squared is 1 minus sine squared. Plus sine minus 2 equals 0. Distribute. So that's 2 minus 2 sine squared. Combine like terms, so positive 2 and negative 2 cancels out. So it's not quite the 2 parentheses factoring. Instead, they both just have a sign, so let's factor out sine. And then solve it. Sine of x equals 0. That means x is 0 plus 2n pi, or pi plus 2n pi. Since 0 and pi are just half a circle away from each other, you could actually combine them. You could just say x equals just half a revolution, so just be n pi. That would sum it all up. Either way is okay. And then for this side, negative 2 sine x, move the 1 over, equals negative 1. Divide by negative 2. Sine equals 1/2 is positive, so it's these 2 quadrants, 1 and 2. It's 1/2, so it's pi over 6. It's pi over 6 and 5 pi over 6 plus 2n pi plus 2n pi. It only wants 0 to 2 pi, though, so there's no change to the period, so the 2n pi's don't actually matter. So x equals 0 is one answer. Pi is one answer. Pi over 6 is one answer. We don't need to add 2n pi to it because that would be too large. And 5 pi over 6 is our fourth and final answer. So with this one, we do have a mixture of cosines and sines, which is not usually a good way to go. So from our formula sheet, or from our formulas, double angle formulas in particular, cosine 2x, we can change that to sines. It's 1 minus 2 sine squared. So even if you had, instead you had cosine of 2x memorized as cosine squared minus sine squared, the only jump to get to the other way of writing it is by replacing either one of those with the Pythagorean identity. So you get 1 minus sine squared or 1 minus cosine squared in either one of them. So yeah, from the formula sheet, this is the last representation of it, which is just the first representation with Pythagorean identity in it. So now we need to get everything on one side so we can factor this out and solve it out. So let's do 0 equals 2 sine squared plus sine x minus 1. We need to factor that. So you can think of those sine squareds and sines just as regular x's. So that's like 2x squared plus x minus 1. It would factor the same way. So it's 2 sine x and 1, and a sine x and a 1. And you just got to get your plus in the right spot and your minus in the right spot. This would have to be plus, that would have to be minus. So that way you get a positive 2 minus 1 is positive 1. So there it is factored out. Set them equal to 0 to solve it. Move the 1 over. Sine x equals 1/2. That happens at pi over 6 in the first and second quadrant. The pi over 6 in the first quadrant and then pi over 6 in the second quadrant would be 5 pi over 6. We're between 0 and 2 pi, so that's all we need to worry about. And sine x plus 1, sine x equals negative 1. That only happens at 3 pi over 2. We have 3 answers. Pi over 6, 5 pi over 6, and 3 pi over 2. Let's solve this out. You can multiply the sine to both sides. Make that be sine squared x equals 3 over 4. Square root both sides. You get plus or minus square root of 3 over the square root of 4, which is just 2. So sine x equals square root of 3 over 2. Any sign, it doesn't matter, plus or minus. So square root of 3 over 2 happens when x is pi over 3. And it's the pi over 3 in any of the quadrants because it's plus or minus. So it's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3.